Hi, I'm Maeve. I've gotten a couple of requests on Tumblr to explain how I rig studio Bionicle models for animation, so I thought I would put together this tutorial video to help some people out. In Studio, make sure that your model has no submodels and that all parts are properly aligned and assigned the correct object colors. Go to File, Export, and export the model as a .dae file to the directory of your choosing. Open Blender and press the A key, and then press the Delete key to remove the default cube, light, and camera. Go to File, Import, collada.dae, then select and import the model that you exported from Studio. Your model will probably import upside down and off-center. To begin fixing this, select all of the objects in the scene by pressing the A key on your keyboard. Press Alt-P on your keyboard and select Clear Parent and Keep Transformation. You might have to do this a couple of times until you don't see any dotted black lines in the 3D viewport. Navigate to the Outliner menu in the top right corner of the window, then select anything that isn't a mesh object. This includes empties, cameras, and lights. Do not select anything that begins with the word object. Press the Delete key on your keyboard. Select a part that is along the center axis of your model. I prefer using whatever part I use for the hips. Press Shift-S and select Cursor to Selected. This will move the little red crosshair to the origin point of the part you've selected. Press Shift-A or navigate to the Add drop-down menu at the top left corner of the 3D viewport and select an empty object. What type of empty does not matter. I tend to use a cube. Scale your empty up so that it is nice and visible. Then select all objects in the scene using the A key on your keyboard. Make sure the new empty that you've created is highlighted in yellow and that everything else is highlighted in orange. If it isn't, just hold the Shift key and select the empty. Press Ctrl-P and select Object from the drop-down menu to set the empty as the parent of every other object. With only the empty selected, press Alt-G to reset its location to the coordinates 0, 0, 0. With the empty still selected, press R as in rotate on the keyboard to begin rotating it. Then, before you click the mouse or press any other key, press Y on the keyboard to lock the rotation to the Y axis of the world. Then, before you click the mouse or press any other key, press 1, 8, and 0 on your keyboard to rotate the empty exactly 180 degrees. This should orient the empty and every object parented to it so that your model is upright. Press A on your keyboard to select all objects, then press Alt-P and select Clear Parent and Keep Transformation from the drop-down menu that appears. You may now delete the empty. If you've done everything correctly, nothing else about the scene will change when you do this. Press Shift-C to return the cursor to the origin of the world grid. Press 1 on your number pad to align your view to a front-facing perspective. If you don't have a number pad on your keyboard, you can emulate it by following the walkthrough that I have included in the description below. While still in front view, press A to select all objects, then press G as in grab on your keyboard to begin moving your model. Without clicking your mouse or pressing any other key, press Z on your keyboard to lock the movement to the Z axis. To the best of your ability, align the very bottom of your model's feet to the horizontal red line running across the screen. This isn't necessary, but makes things a little bit easier moving forward. Now that your model is properly aligned and oriented, we're going to start rigging the model with a skeleton that will allow it to move. Start by pressing Shift-A or navigating to the Add menu and select Armature. To aid visibility, navigate to the Armature properties in the Properties window, scroll down to the Viewport Display section, and turn on In Front. This will allow the skeleton to always render in front of everything else in the viewport. Press Tab on your keyboard to go into Edit Mode, or select where it says Object Mode in the top right-hand corner of the viewport and select Edit Mode from the drop-down menu that appears. Select the bone that appeared in the scene when you first added the armature. Go into the bone properties in the Properties window and change the bone name to Root, R-O-O-T. This is not necessary for this kind of project, but it is a good habit to get into and will be very important if you ever want to export this model to something like Unreal Engine 4. Then navigate to the top center of the viewport and change the transform pivot point to 3D cursor. Now, whenever you rotate any object, it will rotate around the coordinates 0, 0, 0. With the bone still selected in edit mode, press R to begin rotation. Then, without clicking the mouse or pressing any other keys, type 90 on your keyboard. This should rotate the bone so that it is parallel to the y-axis with the smaller end pointing forward. Using the same method as before, change the transform pivot point to median point. Press 3 on your number pad to enter side view. Select the root bone and duplicate it by pressing Shift-D on your keyboard. This will both duplicate it and automatically bind it to your mouse cursor, so that until you click with your mouse, it will follow your cursor. Bring the new bone up close to the back of your model, then click the primary mouse button, which is the left mouse button if you are right-handed, and vice versa if you're left-handed, to set the new bone in place. With the bone selected, change its name to Core, Torso Handle, or something similar of your choosing. For the rest of this tutorial, I will refer to this bone as Core. You can scale an object by pressing S on your keyboard, then dragging your mouse until the object is of the desired size. Click the mouse button to set the new scale. Return to Object Mode and select whatever part of your model you think is the most indicative of your model's hips. Make sure it is a part whose origin has a location X value of 0. Press Shift-S on the keyboard and select Cursor to Selected. Select the armature and return to Edit Mode. Select the tail of the core bone. This will be the end that is at the thinner end of the bone. Make sure that only the ball on the end of the bone is selected and nothing else. Press Shift-S, then select Selection to Cursor. Navigate to the bone properties in the Properties window and copy the Z-axis value of the tail. Then paste that number into the Z-axis of the head. This should make the bone perfectly horizontal. Select the tail of the core bone and extrude it away from the core bone by pressing E on your keyboard. Like with duplication, extruding something will bind the extruded component to your cursor until you click with the mouse. Name this new bone Torso. Return to Object Mode. Find the next highest joint along the model's torso. If you've added articulation to the torso, this may be somewhere along the midsection. Otherwise, this will be the base of the neck. Find the center of rotation of the joint by selecting the part, entering Edit Mode, and selecting two vertices that are exactly opposite of each other. Assuming you have imported your model from Studio and that the joint is made of a ball joint and a socket, the easiest way to do this is to select any vertex on the ball joint and press Ctrl=sign on your keyboard until the entire ball joint is selected. If you've imported your model from Studio, the ball on the part it's connected to is likely not actually connected to the rest of the part, so you can press Ctrl=sign as many times as you want, and it will never select more than just the ball joint. Press Shift-S and select Cursor to Selected. Return to Object Mode. Select the armature and enter Edit Mode. Select the tail of the torso bone. Then press Shift-S and select Selection to Cursor. Repeat this process until you have all bones along the torso and head created, as well as all bones on one side of the body selected. As you do this, keep an eye on the roll of each bone. If a bone looks like it's twisted at a weird angle, select it and press Alt-R to reset the roll. If this doesn't have the desired effect, you can adjust the roll manually in the bone properties. Make sure you name all of your bones or you will hate yourself later. Also, make sure all asymmetrical bones, such as those in the arm and leg, end with .L or .R depending on whether or not the bone is on the left or right side of your model. For example, the upper arm bone of your skeleton should be called or upper arm.L if it is on the left side of your model. Bones at the end of their respective chains, such as fingertips, heads, and toes, do not need to have their tails in a specific location. Keeping them as close as possible to being aligned with the previous bone in the chain is good enough. This next section can be ignored if your model uses arm and leg parts that do not bend at the knee or elbow. Inverse kinematics, or IK, allows the orientation of each bone in a chain to be driven by the location of the last bone in the chain. By comparison, forward kinematics, or FK, allows for the orientation of each bone in a chain to be driven by the rotation of each bone before it in the chain. Inverse kinematics is most useful for arms and legs. Select the tail of whatever bone you're using for the forearm of your model. This will be the same as the head of whatever bone you're using for the hand of your model. Press E to extrude, then press Y to lock the extrusion to the Y axis. Extrude the bone backwards relative to your model. Once you've made the new bone big enough that it can easily be seen and selected with the mouse, click with the primary mouse button to set the bone in place. With the new bone selected, name it Hand IK or IK_hand and add the appropriate suffix depending on what side it's on. .L for the left side and .R for the right side. Repeat this process with the elbow and the ankle. Repeat this process with the knee, but extrude the bone forwards instead of backwards. Select all of these new bones with IK in the names, then Shift-select the root bone. Press Ctrl-P and select Keep Offset to parent the IK bones to the root bone. Move the elbow IK bones directly backwards away from the body, and the knee IK bones directly forwards away from the body. Press Ctrl-Tab or use the drop-down menu in the top left-hand corner of the viewport to enter Pose Mode. Select the forearm bone of your model and navigate to the Bone Constraints properties in the Properties window. Select Add Bone Constraint, then select Inverse Kinematics. Set the target to your model's armature, then set the bone to your hand IK bone. Set the chain length to 2. For the sake of this tutorial, we're going to assume that your model has only 2 bones in each arm and each leg. Select the upper arm bone of your model and add another inverse kinematics constraint. Set the target to the armature again. The armature will be the target for every inverse kinematics constraint in this tutorial. But set the bone to your elbow IK bone. Set the chain length to 1. Select the shin/lower leg bone of your model and add another inverse kinematics constraint. With the target set to your armature, set the bone to your foot IK bone and set the chain length to 2. Select the thigh/upper leg bone of your model and add an inverse kinematics constraint and set the bone to your knee IK bone and set the chain length to 1. Select the foot bone of your model and add a copy rotation constraint. Set the target to the armature and set the bone to your foot IK bone. In the target drop-down menu, select Local Space, Owner Orientation, and in the Owner drop-down menu, select Local with Parent. Repeat this process with your hand bone. With your skeleton selected, switch to Edit mode. Press A on your keyboard to select all bones. Press W on your keyboard to bring up the Armature context menu. Then select Symmetrize in the drop-down menu. This will copy and mirror all bones with a .L or .R suffix at the end of their names, along with any bone constraints they may have attached to them. In Object mode, select all parts that you would want to be driven by the movement of a given bone. For example, you would select any parts in the upper arm that you would want to be driven by the upper arm bone. Shift-select the armature and enter Pose mode. Select the bone you wish to drive the movement of the selected parts. Press Ctrl-P and select Bone from the drop-down menu. Repeat this process for each bone in the armature and all parts you wish for that bone to control. If you so choose, you can parent the hand and elbow IK bones to the core bone. That way, they follow the movement of the torso rather than the root bone. If you want to keep your elbows and knees from rotating in unnatural ways, you can fix this by going into the bone properties, navigating to inverse kinematics, and toggling the Y and Z options in the Lock IK setting. If you do this, you will need to rotate the thigh and the upper arm to point the knee and elbow in the desired direction. Thank you for watching. If you have any questions, feel free to leave them in the comments below. Otherwise, if you have any suggestions for future tutorials, I'd love to hear them.